See electrophilic addition reactions. Right. Keep the heading addition reactions. What are addition reactions and what are the types? Addition reactions. So what are addition reactions? The reaction in which two or more compounds reacted to form a single substance. Okay, the reaction in which two or more substances combine to form a single substance. So generally the reaction in which two or more substances will combine to form a single substance, those are called addition reactions. Okay, so here an unsaturated compound becomes a saturated one, means sp2 becomes sp3. So an unsaturated compound on addition forms saturated one. Unsaturated on addition will become into saturated one, right? Means sp2 or sp carbon will become into sp3, because saturated means all the carbons are filled. Now this addition reaction is classified into three types based on the reagent what it is added. Okay, if the addition reaction is initiated by an electrophile, that is called as electrophilic addition. If the addition reaction is initiated by an electrophile, means first electrophile is coming, after that nucleophile is adding, then that reaction is called as electrophilic addition. Okay, so one thing you remember, in an addition reaction always plus part and negative part will add. जो भी एडिशन रिएक्शन था उसमें पॉजिटिव पार्ट भी ऐड होगा और नेगेटिव पार्ट भी, बट फर्स्ट व्हाट इज एडिंग, बेस्ड ऑन दैट द रिएक्शन इज क्लासिफाइड. अंडरस्टैंड? In any addition reaction, positive part also will add, positive part of the reagent, and negative part of the reagent also will add. But initially, what it will add? Based on that, it is classified. If the addition reaction is initiated by an electrophile, then that reaction is called as electrophilic addition. बाद में nucleophile add होगा. Okay. If the reaction is initiated by an electrophile, then with nucleophile, then the reaction is called electrophilic addition. Understand it? If the reaction is initiated by a nucleophile, means पहले nucleophile attack हुआ, उसके बाद electrophile attack हुआ, तो उस reaction को हम nucleophilic addition. So if the reaction is initiated by a nucleophile and then electrophile is added, then the reaction is called nucleophilic addition. And if the reaction is initiated by an radical, then it is called radical addition. By a free radical, then it is called radical addition. Okay. So in this radical addition reactions are very less, only one or two. Electrophilic addition and nucleophilic addition are important. Okay, we will see one by one. Gargi. Right. Now, what are electrophilic addition reactions? See, don't get confused. Electrophilic substitution means saturated compounds. Electrophilic addition means unsaturated compounds will give. Right? Saturated compounds undergoes electrophilic substitution, like benzene and all. Whereas unsaturated compounds like alkenes and alkynes will give electrophilic addition. So we will take one, electrophilic addition reactions. So generally which type of compounds will give this electrophilic addition? Alkenes. Mainly alkenes. All alkene reactions maximum and alkynes also. Okay. So alkenes undergo electrophilic addition reactions. So what are those? One by one we will see. First one, addition of halogen X2. Addition of halogen means CH2 double bond CH2, या फिर Br2 in the presence of CCl4 is there suppose. So then you will get a cyclic bromonium ion. Br plus will attack here. Actually Br ऐसा होगा delta plus and delta minus. So this plus part will attack and you will get a cyclic bromonium ion. Yesterday I told you, no, onium means what, children? Positive charge. Cyclic bromonium ion is formed and the other part will be there, no, Br minus, that can attack either from this side or this side. So you will get a dibromo product. You will get a dibromo product, but it is trans dibromo product. So here what are the important things? Okay, agar Br, see this is the C double bond C plane. This book you understand, C double bond C. So पहले ऐसा bromine आया. Bromine is very big in size. So the next bromine will come from either this direction or this direction, but not towards up, because bromine is bigger size. So if the bromine is coming like this, then this bromine will go like this. So there will be two bromines, one bromine here and one bromine here. So this addition is called as anti-addition. What is that addition called? Anti-addition. This is an anti-addition, first important point, and you will get trans dibromo product. Trans dibromo product means opposite side bromine will come. So generally you may think that cis and trans means double bond should be there, but this meaning is different. Trans dibromo product is formed. So this is an anti-addition. Okay. Now, competitive point of view, what kind of questions they can ask? So I will tell you one. Here if you take a cis alkene if you take, and if you add bromine, suppose if you take a cis alkene, cis means what, children? CH3, C double bond C, CH3, H and H. This is a cis alkene, and you can take a trans alkene also. So this is competitive point of view important. So what products are formed here? That is they will ask. Can anyone tell what type of product is formed there? Yes, think for a while and tell. Cis alkene is added to Br. So what do you think? Br will come, no doubt. But what kind of compound is that? So here a meso compound is formed. Which compound is formed, children? Meso. Meso means, you know, it has a plane of symmetry, correct? And it is optically inactive due to internal compensation. This is a meso compound. Fine. But if you take trans one, you will get racemic mixture. So racemic mixture means what? Racemic mixture means equimolar mixture of D isomer and L isomer. This all will come under stereoisomerism. So here you will get a racemic mixture. Okay, this is racemic mixture, this is meso compound. Like that you write. I will tell you the clue also. How to remember, I will tell you. 3. Okay, first if you take a cis alkene and do bromination, you will get a meso dibromo product, meso compound. But if you take a trans alkene and if you do addition, you will get a, 1 second children, trans and anti is meso. Just I wrote reverse, don't worry, wait. यहाँ चेंज कर दो, यहाँ चेंज कर दो. Okay. How to remember also I will tell the trick. So if you take trans-alkene and anti-addition, the product is meso. If you take cis-alkene and anti-addition, the product is racemic mixture. So here I will give the tricks to you. How to remember this. Okay, one tabular form if you write now, that will be easy for you. So anytime cis-alkene is taken, cis form, and the addition is syn, then it is meso. At the same time, you take a trans-alkene and the addition is anti, anti means opposite side, then that product is meso. Okay, and if you take cis-alkene plus anti-addition, then you will get racemic mixture. Okay, and if you take trans-alkene plus syn addition, that is also racemic mixture. This is the table children. Okay, means here I have taken a trans-alkene, opposite में था, दोनों opposite में था. This is trans-alkene. And what is type of addition is bromine. Bromine and CCl4 is what type of addition? Just now I told. That is an anti-addition. Like this, double bond is there. Bromine is here. The next bromine is coming from like. So you have to know some reactions which are syn addition, which are anti-addition. Some 6-7 reactions are there. Those if you remember, that is fine. So first point, addition of bromine is which type of addition children? Anti-addition. That you have to remember. So anti-addition and trans. Trans anti. What is the product? Trans and anti. What is the product? Meso compound. Okay. Now this is cis alkene and anti-addition. So what will come? Racemic mixture. Okay. But both are optically inactive. Both are optically inactive. Means they do not rotate the plane polarized light either towards right side or left side. Reason is different. Here internal compensation takes place. Internal compensation takes place. Because of that it is optically inactive. Here external compensation takes place. Can anyone say what is internal compensation and external compensation? Anyone? Don't know. See, one molecule is there. If it is kept in a polarimeter, if it rotates right side, if the plane polarized light is rotated right side, that is called dextrorotatory. If it rotates left side, levorotatory. So in this molecule, half of the molecule rotate right side and other half will rotate left side with equal magnitude. So net will be straight only, it cannot rotate. That is why optically inactive. So that phenomenon is called as internal compensation. Means what? The specific rotation caused by one half of the molecule is nullified by the equal and opposite rotation caused by other half. The specific rotation caused by one molecule, half of the molecule, is nullified by equal and opposite rotation caused by other half. That is called internal. Here external also same thing. The specific rotation caused by one molecule. So agar a molecule right side, if it is rotating, then the other molecule will rotate left side to the same angle. So the PPL light will go straight without any deflection. So that is called external compensation. So that all no need. Just to remember, meso compound is optically inactive, and racemic mixture is also optically inactive. Right? This is over. Next. Now, addition of HBr. That is very, very important point. Addition of HBr. In this you should know what is Markovnikov rule and anti-Markovnikov rule. Yes, we will tell Markovnikov rule. Second addition. Addition of HBr. Correct. So negative charge will go to the double bonded carbon which has less number of hydrogen. Okay. So but say addition of HBr follows what rule? Markovnikov rule. So what is Markovnikov rule? Markovnikov rule. So spelling KOFF also they will give, or KOV also they will give, no problem. Markovnikov rule states that when an unsymmetrical alkene, so it is applicable when both are unsymmetrical. Alkene should be symmetrical, you can't say Markovnikov rule. And if reagent is symmetrical, then also you can't say. Suppose an alkene is like this mark. This is a symmetrical alkene. Markovnikov rule won't be there. Both sides same hydrogen. And the reagent is Br2. This is also Markovnikov rule, you can't say. So both should be unsymmetrical. Means what is the statement? When an unsymmetrical alkene or when an unsymmetrical reagent is added to when an unsymmetrical reagent, I will ask tomorrow, when an unsymmetrical reagent is added to unsymmetrical alkene. So when an unsymmetrical reagent is added to unsymmetrical alkene, then the negative part of the addendum or reagent, the negative part of the addendum. So what do you say? Addendum means reagent only. The negative part of the reagent is added to that double bonded carbon. Is added to that double bonded carbon which has less number of hydrogens or more number of substitutions, which has less number of hydrogens. So that is the rule. What is Markovnikov rule? When an unsymmetrical reagent is added to unsymmetrical alkene, then the negative part of the addendum or the reagent is added to that double bonded carbon. This also you have to say. Negative part is added to less number of carbons means single bond also it can be there. Right? So the negative part is added to that double bonded carbon. Double bonded carbon में किसके पास less hydrogen होता वहाँ attack होगा. Okay? So now you tell this CH3 CH double bond CH2 is there. Now I am adding HBr. So where Br will come, children, and where H will come? So I am giving the numbers now. So where Br will come? Second position, right? CH3, CH, Br and CH. Okay? Like that. So if Br is attacked at first position, that is called as anti-Markovnikov rule. Same, but what you will write? Negative part added to that carbon which has less के place में more रख दो, more number of hydrogen. That's all. That is called our anti-Markovnikov rule. So that anti-Markovnikov rule will come at what? If HBr in the presence of peroxide you add, then what happens? CH3, CH2, CH2, Br. Like that it will come. That is anti-Markovnikov rule. So here many questions are there. I will tell you. Mechanism. Shall I erase? So like this they will ask like exam CH3 CH double bond CH2 HBr and HBr in the presence of peroxide. This is one question. A and B are formed. So here three types of questions they will ask. First question, what are A and B? What are the questions here? What are A and B? This is the first question. Second one, how they are related. means what is the relationship between A and B? How are they related? How are they related? Third one, what type of reactions are it? What type of reactions are those? So these are the three questions. मैंने एक alkene लिया, HBr in the absence of peroxide, HBr in the presence of peroxide. Okay? Understanding? So what are the products formed? The first question. What are the products formed here? So Br will come at less number of hydrogen. So you will get 2-bromopropane. You have to say. Okay. So Br will come at less number of hydrogens and H will come at here. Niranjan, understood? And what is B? B is what? Two products will come. This is the major one. This is B. Br will come here only, no? Okay. Now peroxide के presence में 1-bromo will come. This is the first answer, children. What are A and B means 2-bromopropane and 1-bromopropane. Second one, how are they related? Both are positional isomers. 1-bromo and 2-bromo are which type of isomers? How are they related means they are positional isomers. Positional isomers A and B. Because इसका position अलग था. Okay, two compounds having same molecular formula but different in the position of the halogen are called as positional isomers. Understanding? Now this is important. Third question. What type of reactions are those? And one more point. It follows Markovnikov rule, M rule, and it follows AM rule, anti-Markovnikov rule. That is also called as Kharash effect. K-H-A-R-A-S-C-H. Kharash effect. Anti-Markovnikov rule, what do you say? Doubt, Niranjan, ask. Don't worry, ask. Stand up. नीचे पेन गिरा है. Okay. So what type of reaction is that? First one is what type, children? This reaction is electrophilic addition, and the second one is free radical addition. What is it? Free radical addition. All are addition reactions. These are the three questions which are coming from the equation. Understanding? So mechanism का जरूरत था. Shall I tell the mechanism or not needed? हाँ, ask her.
Free radicals also electrophile.
Yeah, but we will tell separately one. Free radical is electrophile only. It is electron deficient. No doubt. Odd electron species. सही है. But we are classifying into three categories, no? So here initial attack is radical and finally also radical only coming. Okay? Next, immediate question. They will ask like this. A hydrogen, this Markovnikov, anti-Markovnikov rule is applicable only for HBr. Why not for HF or HCl or HI? This is important. Okay? Means, if I take the same compound, children, if I take the same compound and I added HCl in the presence of peroxide and in the absence of peroxide, peroxide के presence में और peroxide के absence में, then both compounds are same. And what is that compound? Both case same compound will come. That is Markovnikov compound only. Here there is no anti-Markovnikov rule. This is very important. Last time they asked. This is applicable only for HBr. I will tell the reason. Okay? Peroxide effect is applicable only for HBr. If you write HCl and peroxide, don't write 1-chloro. दोनों केस में 2-chloro ही आता है. And in two cases, Markovnikov rule only follow. Are you getting my point? Okay? Why means reason is different. Okay? We'll see. Every point covered? Which addition is that? Karash effect. This is what type of reaction, that is what type of reaction. These things are important. Understanding? So HCl case में वो नहीं होगा. The reason is here HF bond is stronger bond than HBr. So HCl bond is stronger than HBr. HCl bond is stronger than HBr. This is somewhat 430 kilojoules per mole to break it, and this is some around 380 kilojoules per mole. Okay, so the free radical cannot break this HCl bond. Free radical can't break which bond? HCl bond. That is why radical mechanism does not take place. Can't break HCl. This is one reason. First reason. Understanding? And why HI won't give? So HCl is only this much energy, means HF, same reason you can apply. HF even more energy will be there now. So then HI energy is less, children. HI energy is less. So it will be some 290 kilocalories only, kilojoules per mole, HI bond. But so free radical can break this. You will get the doubt now. What I am saying, HCl and HF bonds are stronger bonds. That is why we cannot break. Radical cannot break that. Then HCl it can break, no? It will form H radical and I radical. It can form easily. Means the free radical can break the I. But this formed radical again combine with itself to form I2. So first case, free radical cannot break HCl. Second case, free radical can break, but the formed radical does not combine with alkene. That is why I told mechanism. If you know the mechanism, then you will understand. Okay? I'll tell this little mechanism here. So first what happens? Radical mechanism. See children, radical mechanism. Once you look into it, because these reasons are important, and this question also they asked many times. Radical mechanism. First you will take peroxide now. It is radical. In the presence of sunlight, you will get 2 OR radical. This point is clear. In peroxide, first peroxide will split into 2 radicals, 2 OR radicals. After that, our alkene is there now. This alkene, this OR radical will combine with HBr to form ROH and Br radical. This is the second step. OR radical will combine with HBr to form ROH and Br radical. Now that Br radical will come and attack. So there is a 2 possibility here. What is the first possibility? It may come at this here. Then which radical is formed, children? 2 degree radical. And if Br radical may attack at second position, then which radical will form? 1 degree radical. इसमें सबसे stable क्या था? First one or second one? First one is more stable. That is why in next step H radical is coming and you are getting 1 bromo, major one. Understanding? That is why we got 1 bromo in case of radical mechanism. Now this step to break this Pr radical is breaking HBr bond. Understanding? So here that free radical cannot break HCl. That is what I am saying. And that free radical can break HI bond. That free radical means like this. This OR radical can break HI bond, and it also can form ROH plus I dot. It can form like this, children. But after forming radical is attacking alkene, no? Understanding, boys? Radical is coming to alkene, no? Here radical won't attack alkene, and on its own it can combine. Here also radical form, but that radical is attacking what? Alkene. Here I radical does not attack alkene.